Okay. Hello and welcome to another A-level math stream. Today's topic is trigonometry, and I'm solving a lot of questions from D1. So let's begin with the topics. The first question is here in front of me. It says find all the values of x in the interval x is between 0 and 180, which satisfy the equation this. So let me write down the question properly first. I made a mistake the last time. Okay. I see 3x and x is going from 0 to 180, so x has half a cycle. If you go 3x, that means 3 times half, which means 1.5 cycles. Okay, so I will be going in quadrant 1, 2, 3, 4, 5, and then 6 as well. And I will check where I'm positive, negative. Before I do that, I will have to convert this into tan. So I have sine 3x over cos 3x equals to minus 2. That gives me tan 3x equals to minus 2. Tan 3x equals to minus 2. So where is tan negative? Tan is negative in S and C. So I get quadrant 2, quadrant 4, and then quadrant 6 as well. Since I had to do 1.5 cycles, that is what I'm doing. Okay. So then can I say that I can do tan inverse of 2 on my calculator? Let's do tan inverse of 2 on my calculator. So I have tan inverse of 2 on my I'm getting 63.4. The quadrant 2 will give me 3x equals to 180 minus 63.4. Let's see if we get the right answer. 38.9. Okay, quadrant 4 is going to be 3x equals to 360 minus 63.4. The x gives me 98.9. And going from quadrant 2 to quadrant 6, I can say that I have to add 360. So 360 plus 180 minus 64 by 3 gives me 138.9. Okay, that's the first question. Second question says sketch the graph of the curve y equals to 3 sine x. So my idea of sketching the graph is always to use my calculator to draw the table. That is what I'm going to do. I'm going to say that uh, my function is 3 sine x. I want to keep my calculator in radians because I find it difficult to deal with decimals when I'm going to keep my calculator in degrees because I find it difficult to figure out the ranges with radians. So I'm going to go from minus 180 to 180, and I'm going to keep a step of 90. Uh, so what this is telling me is if I sketch this graph, I need a negative side to this as well. So that's 90, it's approximately 90, 180, 180. So minus 90, minus 180, 90 and 180. Okay, I know that I should instead write radians, so that's what I'm going to do. Okay, it's going from 0 to minus 3 first, then to 3, so that's something like this, and then to 3. Okay. Okay, so my curve looks something like that. That's part A. I've made the sketch. The straight line y equals to kx, where k is a constant, passes through the maximum points. It's passing through this point that you have here of this curve for x is between this. Find the value of k in terms of pi. So find the value of k in terms of pi. So I'm going to say if it passes through this point, what I'm going to do is I'm going to insert the coordinates of this point. So the coordinates of this point are 3 comma pi over 2 comma 3. Take these points and insert them here and get 6 over pi. So the value of k is 6 over pi. Yes, that's the correct answer. Let's just find the coordinates of the other point of the original. So I've seen this question before. I think it's a repeated question from the earlier past papers. Okay, now why is this line also passing through 0, 0? I can see that even if I wasn't able to find k, what I can see is that the y-intercept of this line is 0. Okay, so when I have 0, I can insert 0 into the equation as well and say that when x is 0, y is also 0. So I can then get an answer out of it. Okay. Okay, moving on. This is an identity that I need to prove. So I am going to start with the left hand side. And because I know that tan boils down to sine over cos, I'll get a fraction over a fraction. So I'm not doing that. I'm instead converting this into I get cos square x. The cos square x minus sine square x. I've taken a common denominator. There also I've taken a common denominator. So cos square x minus sine square x. I have to take a reciprocal and then say that cos square x plus sine square x is basically 1. And this cos square x cancels out with the numerator. So I get cos square x minus sine square x. I can then change cos square x into 1 minus sine square x minus sine square x. 1 minus 2 sine square x would be my answer. That's question number 3. Moving on to question number 4. I think that's an easy one. It says find the values of a, b, and c. So I can first say that c is the false axis, so c is 3. A is the amplitude, that's width 6. Okay, or I can use the formula maximum minus minimum divided by 2. And I see that this graph has completed 2 cycles, so b is 2. And it says find the smallest value of x in the interval for this. So I am going to do what? I am going to find the smallest value for solving this. Y equals to 0. So I'm going to write my equation first and say that 6 sine 2x plus 3 equals to 0. So 6 sine 2x equals to minus 3. Sine 2x equals to minus 3 over 6. Sine 2x equals to minus half. So either quadrant 3 and 4, C and C. Although it said sine 2x, the idea is I just need to find the smallest value, so that wouldn't be a lot of work. Okay, quadrant 3. First I'll have to do alpha, sine inverse of half, which is pi over 6. Quadrant 3 is equals to 2x equals to pi plus pi over 6. That's 7 pi over 6. And x is therefore 7 pi over 6 into 2. That's 7 pi over 2. Okay, then moving on. We've done questions like these before, so find the exact value of this. What I can do is I can move sine x to the other side and say that I have 2 over 5. Then in order to get cos square x, that's simple. I can say that sine square x plus cos square x equals to 1. So 2 over 5 squared plus cos square x equals to 1. So cos square x equals to 1 minus 4 over 25. That's 21 over 25. And then tan square x is simple. It's just sine square x divided by cos square x. And I can do 2 over 5 squared divided by 21 over 25. So I get 4 over 21 from my calculator. Next, I have the function f such that f of x equals to 3 minus 4 cos power kx. Okay, the k is a constant. In the case where k equals to 2, find the range of f. Okay, so the function that I have is 4 minus cos x whole squared. Sorry, 4 cos x squared. Okay, um, I think my calculator should be able to give me my correct answer. Let me just check quickly and then I will. So I want to go from 3 minus 4 cos x squared. Yep, it's giving me my correct answer. My calculator gives me a table that gives me the values. Uh, Minimum value is -1 and maximum value is 3. So y has to be between -1 and 3. That's what the calculator is telling me. Okay, because of squaring, the values will change. Okay, you can do it manually as well instead of cos x, because cos x can either take the value 0, 1 or -1. So if you're doing it manually, you go 3 minus 4 into 0 square, that gives you 3. 3 minus 4 into 1 square, that gives you -1. Or 3 minus 4 into -1 square, that also gives you minus. Okay, moving on, it says find the exact solutions of the equation f of x equals to 1. Okay, f of x 1. So 3 minus 4 cos square x equals to 1. 3 minus 1 equals to 4 cos square x. 2 over 4 equals to cos square x. I'm going to do it here now. Cos square x equals to 2 over 4. Cos square x equals to half. And the root of half is then two possibilities. One is root 2 over 2. And the other is, from my calculator, it's minus root 2 over 2. So I try to find out alpha. Cos inverse of root 2 over 2. What's cos inverse of root 2 over 2? I think that should be 45 or pi over 4. So what quadrants am I looking at? I'm looking at A and C. Let me see what the range of the question is. It goes from 0 to 80. 0 to 180, so I don't need to go into quadrant number 4 for that matter. And that's S and T, so I just need quadrant 1, which has to be pi over 4. And quadrant 2, which has to be pi minus pi over 1. So my answer should be 3 pi over 4 or pi over 4. Then in the case where k equals to 1, sketch the graph of y equals to x. So my function is going to be f of x equals to 3 minus 4 cos x. Okay, again, I'm going to put this on my calculator and get you an answer. go from 0 to 180, I think. 180. So pi over 2 and pi minus 1 and pi over 2 is 3, so that's 3, and 180 is pi over 7, 6, 7. The graph is going to look something like this. Okay, that's the graph of 3 minus 4 cos x, and it's going to look something like that. Last part says state with the reason whether f has an inverse. Yes, because it is 1 to 1. Okay. Then question number 7 says the reflex angle theta is such that cos theta equals to k, where k is between 0 and 1. Find an expression in terms of k for sine theta. I think I've already solved this in the lecture, and I will quickly go on and solve it again. So this means that it's between 180 and 360, which means that this is either quadrant 3 or quadrant 4. That is cos theta equals to k, where k is between 0 and 1. That means that cos theta is positive because k is a positive number. So it would either be positive with quadrant 1 or quadrant 4, where a and c lie. Okay. Now, in order to find sine theta, what you simply do is you use the identity and you say that sine square theta plus cos square theta equals to 1. Sine square theta is this plus k square equals to 1. So sine square theta is 1 minus k square. Sine theta is therefore root of 1 minus k square. Now I have to decide whether I want to put a plus or a minus. It's why I must then go back and figure out what my quadrants are. So this could be in either quadrant 3 or 4, and this could be in either quadrant 1 and 4, which makes an overlapping quadrant 4. So I know that theta is in quadrant 4, because in quadrant 4 I have reflex angles, and I also have cos theta as a positive number. Okay, so I'm going to say that I am in quadrant 4. In quadrant 4, sine is negative, therefore it's root of minus root of 1 minus k squared. I will discard the positive answer. Why? Because I am in quadrant 4 at the moment. Okay, tan theta is simple. Tan theta is sine theta over cos theta. Over k. Okay, so sine theta over cos theta is this. That says explain why sine 2 theta is negative. So for that explanation, I'm going to say that theta was between 270 and 360 because quadrant 4. 2 theta is going to be between 540 and 720. So makes it quadrant 7 and quadrant 8. Sine of any angle in quadrant 7 and quadrant 8 is negative. Okay, so that solves this question. Then I have question number 8. Okay, question number 8. A tourist attraction in a city is a big vertical wheel on which passengers can ride. The wheel is turns in such a way that the height h meters of a passenger is above the ground is given by the formula this. T is the time in minutes that has elapsed since this passenger started the ride at ground level, and KT is measured in radians. Find the greatest height of the passenger above the ground. Okay, find the greatest height of the passenger above the ground. So let's see what I'm trying to ask you in this question is that I want to go see how high the ride goes. Okay, now there are several ways to solve this. If you remember from before, find this idea of having the angles change affects the x coordinates of the graph. Okay, so it affects the number of cycles. What I can say that cos if I have cos kt, it's going to be k cycles in 0 to 360. Now whenever I'm drawing a graph, okay, what I need to understand here is that a typical cross graph will look like this. Okay, it has a maximum value of 1 and a minimum value of -1, and then there's another critical value called 0. Whatever transformations are happening to this graph will obviously not be at these points when I draw 60 minus 60 cos kt. Okay, why is it not going to be at this point? Because there are a lot of transformations happening to this graph. Now when there are transformations happening to the graph, the maximum and minimum point will change. What we need to understand here is that k affects the number of cycles. It does not affect the height or the depth of the graph. Okay, so can I say that even if cos t was taking on the values 1, 0 and -1, then cos kt will also take on the values 1, 0 and -1. So it's going to be 60 bracket 1 minus, can I say that once it takes on the value 0, then it can take on the value -1, and it can also take on the value 1. These are values for cos kt, not for kt, not for t. Okay, I'm saying that the graph is graph of cos kt will just have a different number of cycles. It's going to have the same maximum minimum values. So you put them into the equation and you get 60, you get 120, and you get 0. So the graph of 61 minus cos kt will go from 0 to 120. So what is the maximum height of the passenger? 120 is the maximum passenger. Okay. This one complete revolution of the wheel takes 30 minutes. Okay. One complete revolution takes 30 minutes. Can I say that at the start of the journey you're on the ground? Okay. And when those 30 minutes have elapsed, okay, let's assume that you're not on the ground. Let's start by doing that. This is 61 minus cos kt. It says one complete revolution of the wheel takes 30 minutes. So that k equals to pi over 15. That tells you that your calculator needs to be in radians. Now, when you have one complete revolution, it simply means that you went from the ground level and came back to the ground level. Okay, so when you came back to the ground level, what is going to happen is that your height is going to be 0. Okay, and the time that would have elapsed would be 30 minutes. So what you simply do is you take 0 divided by 60, say 1 minus cos of 30k. Having my calculator in radians, cos of 30k equals to 1. Now where is cos positive? Cos is positive either in A or C. Okay, let's see if we get the correct answer out of this. So alpha, cos inverse of 0. Cos of 0 inverse of 0 on my calculator gives me cos inverse of 1. Sorry, cos inverse of 1 gives me 0. Okay, so quadrant 1 is the 30k equals to 0. Quadrant 4 is 30k equals to 2 pi minus. Obviously, k can't be 0. then k can definitely be 2 pi over 30, which is pi over 15. Okay, it's a very different question from the ones that you've seen before. Then it says find the time for which the passenger is above a height of 90 meters. So I want to find out when the height is 90. So what I'm going to do on my calculator is I'm going to say that height is 90. I have already found out the value of k, so it's going to be pi over 15t. 90 over 60 equals to 1 minus cos pi t over 15. Cos pi t over 15 is 1 minus 90 over 60, which is 3 over 2. That gives me minus half. Okay, let's take that to the next page and solve. Where is cos negative? Cos is negative in S and T. So quadrant 2 and quadrant 3. Alpha is equals to cos inverse of half. This pi over 6, pi over 3 for that matter. Quadrant 2 is pi t over 15 equals to pi minus pi over 3. Quadrant 2 and quadrant 3. Okay, what does that give me? That gives me 2 pi over 3. Pi cancels with pi, 3 times 5, so t is 10. So it's at a height of 90 meters at 10. And then again, it's at a height of 90 meters at, find this number, 20. So for how many minutes is it at a height of 90 meters? Above height of 90 meters, that's what the question is asking you. So it was during this time that the graph was above a height of 90 meters. So 20 minus 10 gives me 10 again. Okay, that was a tough question, but that is how you would solve it. Okay, moving on to the next one. It says prove the identity 1 over sine x minus 1 over tan x squared equals to this. Okay, so without first expanding, what I can do is I can tell you that tan x is basically sine x over cos x. So 1 over tan x should be cos x over sine x. What that helps me do is it helps me combine the denominators without having to do much. So I then have 1 minus cos x whole square and sine square x. Looking at the answer that I have on the right hand side, what I can say is that I want 1 minus cos x. So there might be a possible way of cancelling out the square somehow. That's what I'm going to do. I'm going to say that 1 minus cos x squared equals to this. I can say sine square x is basically 1 minus cos square x. Now, how do I get from 1 minus cos square x to 1 plus cos x in the denominator? Now, what you need to remember is that there's a lot of algebra involved in these identities sometimes. Can you see that if this is a square and this is b square, I could possibly factorize this, because a square minus b square factorizes to what? It factorizes to a plus b and a minus b. So this becomes 1 minus cos x and 1 plus cos x. So 1 minus cos x cancels out. I have then 1 minus cos x and 1 plus cos x. Part 2 says, hence solve this equation. So I'm going to borrow from the first part. Cross multiplying Okay, so 3 equals to 7 cos x. Cos x equals to 3 over 7. I have A and C, the quadrant 1 and quadrant 4. The 4.6. So quadrant 1 equals to x equals to 64.6, and quadrant 4 equals to 189 4. Quadrant 4 equals to 360 minus 64. If those are the correct answers, or this question had to be solved in radians and I don't know what the correct answers are. Okay, let me solve this in radians again for you. So 1.13. The quadrant 1 is 1.13, quadrant 4 is 2 pi minus 1. So 2 5.15, I think. Okay, then question number 10 says, catch and label on the diagram the graphs of y equals to 2 sine x and y equals to cos 2x for the interval x is between 0 and pi, hence state the number of solutions. Okay, let's first quickly sketch. They just wanted from 0 to pi. Okay, so I have my tables on my calculator, so I'm going to use to solve this question. And if I say that it starts from 0, so 2 sine x would just be something like this, 1 and 2. Okay, and then cos 2x would look something like this. We're going to start and have smaller intervals because it's cos 2x. It's going to look something like this. Okay, so that's sketch and label. So label as well. State the number of solutions. The number of solutions of this equation is basically simultaneously solved. So how many intersection points do I see? I see 2 intersection points. So 2 solutions. Okay. That brings us to the end of worksheet 1. Let's start doing worksheet 2. It says express the equation this in the form tan theta equals to k. So I'm going to say that sine theta over cos theta will give me 1 over 3. Okay, so that makes tan theta equals to 1 over 3. Let's solve the equation for 0 to 180. So I'm going to write down my quadrants first. I'm going to say that they can either be in A or T. Quadrant 3 is beyond 180, so I'm going to ignore that. Tan inverse of 1 over 3. I'll need my calculator again in radians. Degrees, sorry. Calculator was in radians. 18.4. So quadrant 1, basically 18.4. Quadrant 3 would be outside the domain. Okay, part 2 then says 3 sine square 2x equals to cos square 2x. So sine square 2x over cos square 2x equals to 1 over 3. That gives me tan square 2x equals to 1 over 3. Okay, quadrant 1 and quadrant 3 again. Okay, sorry, wait. I think I have missed out the fact that this is a root, so it's going to give me both plus and minus. So tan 2x equals to okay, and then minus root of 1. So this is quadrant 1 and quadrant 3, quadrant 2 and quadrant 4. I'm going to mark all the quadrants because it's 2x and x was 0 to 180, so 2x means that I have at least one complete cycle to work with. Okay. What's tan inverse of root of 1 over 3? This means 80 degrees. Quadrant 1 is 2x equals to 30, x equals to 15. Quadrant 2, quadrant 3 is 2x equals to 180 plus 30. Quadrant 2 is 2x equals to 180 minus 30. Okay, so there is 4 answers. Let's start solving this, proving this. Let's see. So whenever I have a fraction upon a fraction, what I would want to do is I would want to write it as a divide sign and replace tans with sin x and cos x. I get, if I take an LCM, I get sin x plus cos x divided by sin square x over cos x plus cos x. I can't yet take a reciprocal because I don't have a common denominator here. Okay, so cos x gives me cos square x. That makes it cos x over sin square x plus cos x. Sin x where this gives me 1. That is what the question was asking you to prove. Okay, then it says hence solve the equation. I'm going to replace this whatever I have right now. Because x marking my quadrants now. Over 2. I keep my calculator at radians now. Minute 3. Quadrant 1 is 0.983 and quadrant 3 is 5 minus 5 plus 4.1. Okay, let's look at the next one. It says y equals to a plus b sine x. Take the values of a and b. So a is the false axis here, so a is 1, and b is the amplitude. So that's then I have to prove this identity: tan square x minus sine square x. Okay, so the first thing that strikes me is maybe I need to do sine square x over cos square x. Let's take it up 5. Then I take a common denominator, working with the left hand side. Sine square x minus sine square x cos square x. I factor out to sine square x and say that that gives me 1 minus cos square x. And then what is cos square x? 1 minus cos square x is again sine square x. That sort of solves my problem. What I can do is then say that this part equates to tan square x. And there's a sine square x remaining. Prove the identity. Okay. Question number 5 says it is given that a equals to sine theta minus 3 cos theta and b equals to 3 sine theta plus cos theta, so that a square plus b square has a constant value for all values of theta. A square plus b square. So sine theta minus 3 cos theta square plus 3 sine theta plus cos sine square theta. A square to ab plus b square square theta plus sine cos square theta plus cos cancelling out. Yes, the I see 10 sine square theta, 10 cos. What I then do is I can take this common and that's what 10 to 1 10. That proves that regardless of the value of theta that you have here, and then if you do a square plus b square, the answer is always going to be 10. Okay, that is how you prove that it is a constant. Value of theta does not matter, then values of theta, a square plus b square will always be 10. Then it says find the values of theta for which 2a equals to b. So I'm going to say 2a equals to b. So minus 7 cos theta equals to sine theta. Minus 7 equals to sine theta over cos theta. So SNC, let me see, theta is from 0 to 360. Calculator is again. 81. Alpha is equals to tan inverse of 7. 81 point. Okay, 98.1. Yes, that's the correct answer. Quadrant 4. 78. Okay, then we have this. It says sketch the curve y equals to 2 sine x for this. Zero to 2 pi. Pi over 2, pi, 3 pi over 2, and 2 pi. So what I'm going to do is I'm going to use my table to use my calculator to construct a table and then try to sketch this graph. And it's going to start from 0, then go to 2, then this, and then that, that. There's a lot of charging issues right now. Keep that for later then. Okay, that is the graph of 2 sine x. Then it says by adding a suitable line to your sketch, determine the number of real roots of the equation. Now I see here what I've ended up doing is I've solved something simultaneously. Okay, what curve did I have? 2 sine x. Can I isolate 2 sine x and say that this has to be on the other side where pi is divided? Okay, so what I know is that one of the curves that I've already drawn is 2 sine x. If I draw this other curve on my graph, that means I will be solving simultaneously on a graph. Okay, pi, sorry. Okay, so what sort of a curve is that? If I break this pi up, pi is basically a number. So what is this graph? This is basically a straight line graph with a y-intercept of 1 and a gradient of 1 over pi. Y equals to mx plus c. So m is 1 over pi. Okay, one of the points on the graph is the y-intercept is 1. How do I know what other point I can plot? I can pick up any coordinate on the x-axis. I can pick up pi over 2, I can pick up pi, I can pick up 3 pi over 2. So what I'm going to do is I'm going to pick up x equals to pi and see where the graph lands. Luckily, it lands on 0. So I know that the other point that the line is passing through is this point. Okay, and I then try to sketch a graph, straight line. So it says, by adding a suitable line to your sketch, determine the number of real roots of the equation. This, state the equation of the line. So I've already stated the equation of this line to you. How many solutions do I see? How many intersection points do I see? I see 3 intersection points. So whenever you have one of the graphs and then I give you an equation, what you need to do is you need to figure out where that equation is. Isolated on the left hand side or the right hand side, whichever side is convenient. There are a couple of questions like that on the past papers. Okay, I don't know if there's a question P's and Q's and so on. Okay, there are some long questions coming up. Okay, going through this question then, question number 7. It says, show that the equation 2 sine x plus tan x plus 3 can be expressed in the form. So 2 sine x over cos x. So 2 sine square x over cos x equals to 3 minus 3 on the other side. So 2 sine square x equals to minus 3 cos x. I can write this as 1 minus cos square x. Okay. So I proved to you the equation, then it says solve. So I'm going to solve this equation, say that this is a quadratic basically with as2, bs minus 3 and cs2 again, cs minus 2. And minus 0.5. So cos x equals to 2 and cos x equals to minus 0.5. So obviously this has to be discarded because cos has to be between 1 and minus 1. It won't work on the calculator either. So minus 0.5 can either be in S or in T. Cos inverse of minus 1 or cos inverse of 0.5 is 60 degrees. So quadrant 2 is 180 minus 60 and quadrant 3 is 180 plus 60. So the answer can either be 120 or 240. Then the next question is question number 8. It says the graph of the equation this, stating the coordinates of the point of intersection with the y-axis. Okay, so I'm going to draw this again. Okay, that's pi over 2, that's pi, that's negative pi over 2, that's negative pi. The graph of cos x looks something like this. It goes like that. Turning a little too quickly. Okay. Then I have something that looks like that on the negative side as well. Okay. I do this with the table on my calculator. Oh, okay. That was 2, so I should have drawn it at 2. Sorry, my bad. So, okay. That's 2 and that's minus 2. Okay, then it says point P and Q lie on the curve with have x coordinates of 1 over 3 pi and pi respectively. So I am either on here or 1 over 3 pi is basically 60 degrees around here. That's P. And that's pi. So I see the y coordinate of pi as well. So I'm going to write minus 2. Find the length of PQ correct to 1 decimal place. So I'm going to have to find what The y coordinate of this is, I think it's going to be 1. Okay, so I have distances 1 over 3 pi comma 1, distances between the points P and Q. So that's, I think, simple. Y2 minus y1 whole square and x2 minus x1 whole square. Let's see if we get the correct answer. And then the inner root. So I'm getting 3.658. One decimal place would give me 3.7. Okay, then the line passes through P and Q, meets the x-axis at h comma 0. And the y-axis at 0 comma k. Show that h equals to 5 over 9 pi and find the value of k. Okay, so it's basically just finding x and y intercepts. So I'm going to rely on my idea of y minus y1 mx minus x1. I'm going to first find the gradient and say that the gradient is y2 minus y1 over x2 minus x1. So that's going to be 9 pi over 2. Minus 9 pi over 2. And what points am I going to take? I'm going to take the easier set of points. I'm going to use minus 2 and pi. So if I want to show you h, what I'm going to have to do is take y as 0. So this is going to become 0 plus 2 minus 9 pi over 2 equals to x minus pi. When this gets cross multiplied, it gives me minus 4 over 9 pi equals to x minus pi. Okay, this is going to get multiplied and that is going to get divided. So x is then pi minus 4 over 9 pi, which is 5 pi over 9. Okay, and then to find the x-intercept or y-intercept, I have to keep x as 0. So that gives me minus plus 9 pi squared over 2 minus 2. That's going to be a calculation that I have to do. And pi squared divided by 2 minus 2. I messed something up. That's 2.5. Yeah, the answer looks like it should be 2.5. I'm getting such a weird answer out of this. Not sure what error I'm making. Let me just check quickly. Oh, I have made a very silly mistake, I think. This pi is not in the numerator, it's in the denominator. Okay, I've totally sort of skipped that part. So yeah, that's what I was worried about, that I wasn't getting something right. Okay, let me write this again. Weirdly, I'd made a compensating error on the other side. Give me the right answer then. Okay, so that's 9 over 2, and minus 2 gives me 4.5. Okay, let's look at question number 9. It says the diagram shows the graph of a plus b sine x. Find the values of the constants a and b. So I can see there's a false axis emerging. So that should be the value of a. A should be minus 2. Okay, and this, as I see, is the amplitude. So amplitude has to be 3. Yep, those are the right answers. Then it says show that the equation this can be expressed as this. So that's a complicated equation. Let's start multiplying. Sine theta plus sine theta, sine square theta minus sine theta cos theta. I've multiplied sine theta with the entire second bracket. Then I have 2 cos theta plus 2 cos theta sine theta. A lot of terms there. And then minus 2 cos square theta. On the other side, I have sine theta plus sine theta cos theta. Bring everything to one side, so I get sine theta plus sine square theta minus sine theta cos theta plus 2 cos theta plus 2 cos theta sine theta minus 2 cos square theta minus sine theta minus sine theta cos theta. Let's see what terms are adding, subtracting, or cancelling out. I saw this, and together these cancel out. So I'm left with sine square theta plus 2 cos theta minus 2 cos square theta. So I'll change this to 1 minus cos square theta so minus 3 cos square theta I think I have that form, just that the signs are different. So taking everything to the other side, that says hence solve the equation from minus 180 to 180. Then we'll first have to put this on a calculator and find this. A is 3, B is minus 2, and C is minus 1. One and minus 0.33. Okay, there's a bit of a negative cycle and a bit of a positive cycle. Where is cos positive in A and C? So I'm going to calculate quadrant 1. Cos inverse of 1 is 0. So quadrant 1 is theta equals to 0. Quadrant 4 is theta equals to 360 minus 0. That's 360. To find the negative cycles, what I've told you is that you can subtract these answers from 360. So your answers for the negative cycle would be, in this case, would be 0 minus 360 would give you minus 360, and 360 minus 360 would give you 0. Both 360 and minus 360 are outside the given limits, so I will discard them. For this, you have S and C, so you calculate quadrant 2 and quadrant 3, sorry, S and T. So shift cos inverse of 70.7. Okay, so I have two answers. I've calculated the wrong quadrants. $109.3. I think I 0.333. Yep, that's 70.55. Okay, I didn't take as accurate as I should have, so that's giving me an error. In any case, that should be 109.5, and that should be 180 plus 70.55 to 50.55. Okay, both of these would then be subtracted from 360 to get the negative cycle. My tablet is malfunctioning a little. As soon as the stream ends, I'm going to fix that. And 250 point. Okay, you subtract those from answers from 360 to get both positive and negative 109.5. Okay, if you subtract 250.5, if you do 250.5 minus 360, that's okay when your answer will turn up. Okay, let's do this last question quickly. Try to fix this quickly. Okay, so 2 cos square theta goes to 3 sine theta. So 2, 1 minus sine square theta equals to 3 sine theta. 2 minus 2 sine square theta equals to 3 sine theta. So A is 2, B is 3, C is minus 2. Point 0.5 and minus 2. So not possible because sine has to be between 1 and minus 1. For this, I get quadrant 1 and quadrant 2. I find out alpha, which is sine inverse of 0.5. That has to be 30 degrees. The quadrant 1 is 30 degrees. Quadrant 2 is 180 minus 30 degrees. Okay. Then says the smallest possible solution of the equation this, where n is a positive integer, is 10. State the value of n and hence find the largest solution of this equation. Now, what I need to remember is that what n simply means is that what we've learned before is that n cycles are there. Okay. So if there are n cycles, the smallest answer will still be in the first cycle. And if the smallest answer is 10, what I can tell you is that quadrant 1 was theta previously, now it's going to be n theta, and that's equals to 30 degrees. To find out theta, what I do is 30 divided by n. That's the smallest possible answer. And what is that equals to in this case? It's equals to 10, which means that n should be 3. So if there were 3 cycles, the answers for quadrant 1 would be for 3 theta, and the first answer is going to be 3 theta equals to 10. Now, if there are 3 cycles of this question, okay, what I can say is that after quadrant 1 and 2, there would be quadrant 5 and 6. And after quadrant 5 and 6, there should be quadrant 9 and 10. Okay, to go from, if I want now the largest answer, I'm going to go into quadrant 6 and then quadrant 10. To go to quadrant 6, I add 360 and then another 360. So my answers are going to be 3x equals to 360 plus 360 plus 180 minus 30 degrees. Okay, that is the answer in quadrant 10 that I'm going to get. Three sixty plus 360 plus 180 minus 30, and then divide by 3. So the answer that I get for x is 290, or theta equals to 290, and that's the correct answer. I think that brings us to the end of both worksheets, and I hope this was a productive session for you. Thank you for watching.